Hello, and welcome back to the Cracking FAANG YouTube channel. Today we're going to be solving Leetcode Problem 1891, Cutting Ribbons. Before we start this problem, I just want to say that this question is very similar to my video that I did on, I believe it was capacity to ship packages within D days. The setup is actually going to be very similar. So if you haven't seen that video, I would highly recommend watching it first because it's much simpler than this one. This one is a little bit more annoying. It's harder to set up, and knowing how to solve the other question will help you a lot with this question. So if you haven't, pause the video now, go watch that video, come back, and then do this question. Otherwise, this one's a little bit harder to wrap your head around, but it's basically going to be the same thing. So that being said, let's now read the question prompt. You are given an integer array ribbons, where ribbons of I represents the length of the ith ribbon, and an integer k. You may cut any of the ribbons into any number of segments of positive integer lengths or perform no cuts at all. For example, if you have a ribbon of length 4, you can keep the ribbon of length 4, cut it into one ribbon of length 3 and one ribbon of length 1, cut it into two ribbons of length 2, cut it into one ribbon of length 2 and two ribbons of length 1, or you can cut it into 4 ribbons of length 1. Your goal is to obtain k ribbons of all the same positive integer length. You are allowed to throw away any excess ribbon as a result of cutting. Return the maximum possible positive integer length that you can obtain k ribbons of, or 0 if you cannot obtain k ribbons of the same length. If we look at an example here, and we're given ribbons of length 9, 7, and 5, and we're told to find k equals 3, then our output's going to be 5. And the reason for this is because we can cut the 9 into two ribbons, one of length 5 and one of length 4. Then we can cut the second ribbon into two ribbons, one of length 5 and one of length 2, and then we can keep the third ribbon 5 as it is, and then we'll have 3 ribbons of length 5, and that's going to be the longest cut that we can get. So much like capacity to ship packages within D days, how they actually derive this 5, it doesn't make sense. You look at the example and you're like, okay, cool, I understand how you got 5, but how in the world do you actually derive this? And this is where this problem is a little bit annoying. So let's now dive into the actual explanation of how to set this problem up and how to solve it. So let's do that. Okay, so we read the question prompt and we looked at an example, but it wasn't very clear from the example how they actually derived the answer. It didn't really make sense. It wasn't intuitive. Yeah, we could follow the logic, sort of, but how did they actually come up with that solution? It seems like it was just pulled out of thin air. Well, similar to how we solved capacity to ship packages within D days, let's work through and try to find an intuitive solution to this problem. So if we think about it, what's the smallest ribbon length that we can get when making a cut? Well, it can't be 0 because we can't cut something and then get a ribbon of length 0, right? That's not possible. Either we don't cut something in which it stays the same length, or we have to make a cut in which we get 2 ribbons, depending on whatever the cut size is. So logically, it follows that the smallest ribbon size we can cut something and receive a ribbon, is going to be 1, right? You know, if we cut the 9, we could cut it into length 8. That way we would get 1 of length 8 and 1 of 1. So, our left boundary is going to be a 1 here. Well, what's our right boundary? Well, say we chose 10 as our right boundary. Could we cut, 9 into 10? No, we couldn't do that for 7, and we couldn't do that for 5. What would end up happening is if we chose 10, is that we would simply just not make a cut at all, right? If it's greater than the current length, then we can't make any cut. So what this means is that there's no point of choosing a maximum cut length greater than whatever the maximum of our array is. Anything greater than that, we could choose 10 billion, 100 million, doesn't matter. We would always just keep it of the same length because we can't make that cut. So anytime that the ribbon length is the cut we want to make is actually larger than the current ribbon, that means that we just have to keep the ribbon the same size, right? We can't cut something of length 5 in 8, right? It's just not possible. We could do that for 9, but not for 5. So it follows that our right boundary is going to be whatever the maximum of our, ribbons is, right? So that is our maximum. So that means, for this problem, we would have all potential cut lengths, which is going to be 1, 2, 3, dot, 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 all the way up until 9. So these are our potential cut lengths that we could choose. And basically, similar to, the problem where we were shipping packages, we now have an ordered range, which is increasing by 1 each time, which means that this range is sorted. Now we could crawl this array from left to right to basically say, okay, well, let's try a cut length of 1. What are the ribbons? What are the maximum ribbons we can get? And, is that less than or equal to k? Okay, let's try 2, 3, dot, 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 dot. But remember, we have this sorted range here, so we can actually do a binary search. And what we want to do is essentially just find the ribbon length that will maximize give us the maximum possible integer length that we can obtain k ribbons of. So, what we need to do again is going to be 1, we're going to set up the binary search. And then 2, we need some sort of can cut function that will tell us, if we use a ribbon length, say 2, can we cut at least k ribbons for that? And what we want to do is we want to keep going, forward, trying bigger and bigger cut sizes until we can no longer make the cut. And then whatever the previous cut was will be the maximum. Because, say we try, 3 and that works, but then we go to 4 and we can't make that cut size. Well, there's no point of trying anything to the right of 4, because if 4 doesn't work, then larger sizes won't work. And then if we know that 4 doesn't work, then the best answer is going to be the one before it. So that's how we want to set up our binary search. It is a little bit trickier because, again, we're working with these kind of you're not returning an index, you're kind of just letting the binary search play out and then returning either the left or the right pointer as your final solution here. So let's go into the editor and we're going to write the code for this problem, because it's going to be a little bit easier to visualize once you see how it's implemented as opposed to kind of drawing it out. So I'll see you back in the editor. Okay, we're back in the editor. Now let's write the code. The first thing that we want to do is set up our left and right boundaries for the binary search. So remember that the smallest possible length we could cut was going to be length of 1, right? We could cut something and the smallest ribbon length that we could receive is 1. So we're going to say left equals 1, and remember the maximum possible ribbon length we could receive would be the maximum of our ribbons. So this would be the case where we just don't cut that maximum ribbon. So it's going to be whatever the maximum of ribbons is. So we're going to say max ribbons for the R. Now it's time to set up our binary search. And the reason why I don't like this problem is because setting up the binary search here is actually not very intuitive. It's very similar in nature to how we solved capacity to ship packages within D days, but it is slightly different, and it doesn't really make sense why unless you draw it out and you work through an example, which isn't always the most intuitive. So what I'm going to do is I'm going to write the code, and then we're going to go back into the diagram and I'll walk through the solution as to why we want to do it this way. So if it doesn't make sense in the beginning, it's okay. We'll go through the example, and hopefully by then when I draw it out line by line, it'll make sense. So as with our binary search standard, we do while low, and here's where it starts to get a little bit messy. We're actually going to do while while left is less than or equal to right. And what we want to do now is we want to find the midpoint. So midpoint is always going to be left plus right, and then integer divide by 2. Now we need a helper function to tell us whether or not we can actually cut the ribbons into our length mid here and receive at least k ribbons, right? Because that's our criteria for how we're going to move our binary search up or down. So we're going to say if self.canCut ribbons, and we're going to pass in k and we're going to pass in mid as the length. if we can cut this, then that means that, we found a potential solution. So anything to the left of this length, we don't have to bother trying, because if we can cut this length, then everything below it will not matter, right? Because we will get a smaller ribbon length if we do that. Remember, mid is the length of the ribbon that we're getting, not the amount of cuts we can get. This is where this problem is a little bit confusing. So if we can cut, size mid and get at least K, then we don't want to try any smaller cuts, because remember, we're trying to maximize the maximum, cut of the ribbons that we get. So what we want to do here is we want to say left needs to move up to whatever mid is plus 1. Otherwise, if we weren't able to cut, what we want to do is we want to move our right pointer to mid minus 1. And again, if this doesn't really make sense, we're going to go back to the drawing board and I'll show you why you have to do it this way. It is a little bit confusing, but you'll see once I draw it out. So, the binary search will proceed as usual. And at the end, what we want to do is we want to return our right here. And now what we need to do is we need to define our can cut function. So we're going to say def can cut, and we're going to take in, our ribbons. We're going to take in K, and we're going to take in the length that we want to work with, or that we want to cut with. So the amount of ribbons that we have, we need to keep track of. So we're going to say cut equals 0. So this is the number that we were able to cut using this cut length to get, ribbons of that length. And we're going to say for ribbon in ribbons, we're going to say cut is going to be plus equals to ribbon integer divided by length. All right. So what we're going to do is, say if this was 9, like in our example, 9, and we were working with, a cut of 5, we would cut this into 4 and 5. And since we're working with, the length 5 here, we would increment it by 1, because obviously 9 divided by 5 is going to be, when we do the integer division and truncate it down, it's going to be 1. At the end of the day, what we want to do here is we simply want to return whether or not cut is greater than or equal to K. So whether we were able to cut using the length of length and receive at least K ribbons, which is what we were asking for, right? And if we can, then, we're going to return true. Otherwise, we return false. And that's going to determine, what we do here in the while loop for the actual binary search. So this is all you have to do for this problem. Let's submit this and double check that it works. And we can see that it does. Okay, cool. So in terms of time and space complexity, we will talk about this back in the diagram where I walk through the example. So hold tight, and I'll see you back on the drawing board to go over, our solution, why it works line by line, and also what the time and space complexity is. So I'll see you there. Okay, welcome back to the drawing board. Now let's go over this example line by line. So if you recall, the first thing that we did was we figured out what our left and right boundaries for the binary search were. So on the left side, it was going to be just 1. And on the right side, it was going to be whatever the max of our array is. So as we can see here, the max is going to be 9. So let's draw that out real quick in terms of, our search space. So we have all the values from 1 until 9. Cool. So remember that our while loop that we set up in the array was going to be, while left less than or equal to right. So, is left less than or equal to right? Yes, it is. So that means that we still have some processing to do. So we calculate the midpoint. So it's going to be 1 plus 9, divide by 2. And this is going to give us what? 5, right? So our midpoint is now this 5 here. And we're going to try, okay, can we cut with the length of 5? So if you remember, the way that we do the cutting is basically, we go for ribbon and ribbons, and we do, the ribbon integer divide by whatever the length is, right? So let's do that. So we'll go, we have originally 0 cut, and okay, we're going to go 9. What is 9 divided by 5? It's going to be, when we do the integer division, it's going to be 1. So then we do the same thing for the 7. So we're going to add a 1. And then we're going to do the same thing for the 5. So obviously this is going to be, it's going to be 1 here. So, at the end, if we use, this 5 here, we're going to get, k equals to 3. So since, k equals 3, and we were looking for whether or not cut was, less than or greater than or equal to k, using 5 will work. So we know that a length of 5 will work, which means that everything to the left of 5 is now an invalid length, because there's no point of choosing a shorter cut length, because remember, we're trying to maximize this cut length. So obviously using a smaller one would be stupid. So what we want to do is now, okay, so remember that if we can cut it, what we end up doing is we are going to say left is going to be whatever mid is plus 1. So mid is 5, so we're going to say left is now going to be mid plus 1, so that's going to be 6. Okay, so now let's do our while loop again, because 6 is still less than or equal to 9. So now we go 6 plus 9, which is going to be 15, divided by 2. That's going to be 7.5, and that truncates down to 7. So, our midpoint is now, so left is now here. Left is at the 6, and right is at the 9 still. And now we're here as our midpoint. So we're going to try, again, cutting with length 7. So let's try that. Okay, what happens when we cut the 9? We're going to receive a 1, right? Because we can cut it into length 7 and length 1. So we received 1 ribbon of length 7, which is what we're looking for. If we cut the 7, we just don't cut it at all, and we just stay with the 7. So we get 1. And we actually can't cut the 5, because we can't get a ribbon of length 7 by cutting 5. So we get a 0 here. So the total number of ribbons we get is 2, which is not, greater than or equal to k. So that means that this 7 doesn't work. So 7 would not be a valid answer here. So in this case, when we can't cut it, remember that, okay, well, if we can't cut 7, then everything to the right of it is an invalid answer, right? If we can't cut 7, then there's no point of trying 8, 9, and on and on and on, because if 7 doesn't work, then nothing greater than it will work. So in this case, what we do, remember, is we're going to set our right equal to mid minus 1. So mid minus 1, if mid is 7, then that means mid minus 1 is going to be 6. So we now have, okay, left is 6, right is 6. So we do have the left less than or equal to right. So that means that we still have to continue. So now we're going to say, okay, 6 plus 6 into divided by 2. So 12 divided by 2. So this is going to be 6 for our midpoint. So the midpoint is now 6. So now let's see if we can actually make the cuts here. So left is now here, and then right is also 6, and we're working with this one, right? So let's do it. Okay, so if we do 9 into divided by 6, we're going to get 1. We do the same thing for the 7, we're going to get 1 back. And if we try 5, obviously we can't cut 5 and get a ribbon of length 6. So that means that we would just have to leave 5 as it is. So that means that we don't get anything back here. And again, we get 2, which is not, greater than or equal to k, which is 3, which is the minimum that we need. So 6 is not a valid answer. So remember, if we can't cut, then the right must go to mid minus 1. So this is going to go equal to 5. And now we have broken our while loop here, because now left is no longer less than or equal to right. So that means that we have finished. So at this point, remember, we want to return the right, which now will have moved, because remember, we move it to 5. So 5 is actually our answer here, which is what we expect. If you remember back to the original example, when we did it, the answer for this one was 5. So that's why we're returning the right here. Again, this problem is a little bit weird, especially with this less than or equals to right mumbo jumbo, and then we're subtracting 1 from the mid, adding 1 to the mid. In the previous problem, capacity to ship packages, it was a little bit more intuitive how it was working. There is a way to set it up in which it does follow that pattern, except now our original right gets set to the maximum plus 1, which isn't very intuitive in and of itself. I think it makes more sense to just start it off with 1 and then the maximum, and then deal with this mumbo jumbo inside. But it's up to you, whatever makes more sense to you. You can read the Leetcode comments and some of the other problem solutions to figure it out for yourself, whichever one kind of clicks for you more. This is the one that makes sense for me. I can definitely see why, returning right here is the correct answer and how it, converges to what we need. You could probably just walk through this portion with your interviewer for the logic and they should be able to follow you. So that's how you essentially want to solve this problem. Before we go, let's just touch on the time and space complexity. So, to do the cutting, obviously we're going over all of the ribbons to figure out how many we can cut. So it's this portion. So that part is going to be big O of n. And, obviously we're doing a binary search. And, the binary search is going to actually be big O of log k, where k is basically the spread between 1 and whatever the maximum is, right? So that, this range here that we have is going to be of length k, and that's what we're searching over. So that's why we have log k here. Special thanks to one of my viewers who actually pointed this out for the capacity to ship packages problem. I think I got the time complexity off there. So this is what we actually want to use. So it's going to be n log k for the time. And then space-wise, it's going to be a constant space solution because recall that we don't actually use any extra data structures. We just have two variables to store the left and the right. So that means that, this is just going to be a constant space algorithm. So this is the best that you can do. It's going to be an n log k for the runtime and a constant space on the like a space complexity. And yeah, that's how you solve this problem. Leetcode problem, what is it? 1891, cutting ribbons. It's a bit weird. It does follow the same pattern as a lot of binary search questions, just figuring out how to set it up. It is a little bit more tricky. I definitely don't like this question, but hopefully this video explained things in a way that was a little bit more intuitive, and you can actually, figure out how to do this and kind of just, if you need to, memorize the solution. And I think it's quite easy to walk through the logic, even if you have it memorized, so it's not completely obvious that you're just regurgitating. I think it is a little bit easier to understand once you've seen it. So if you found this video helpful, please leave a like, comment, subscribe. If you'd like to see any videos, let me know in the comments section below. I'll be happy to make those videos for you. Anything you guys want, just tell me the question, or maybe if you just want like general topics, just let me know. I'll make the videos. Happy to do that for you guys. So happy LeetCoding. Bye.